Another type of problem we may see is we may be given a derivative in factored form already, and we have to determine the critical points of f of x given the derivative. So again, we should start by making a table by splitting up our intervals based on where our derivative is equal to 0. So our derivative 0 at x equals 3, at x equals 5, and x equals 7. So we'll go from negative infinity until 3, go from 3 to 5, okay, 5 to 7, and 7 to infinity. Okay, we want to take the sine of f prime x and then say what's happening to f of x. Okay, so we first want to figure out the end behavior of f prime, and we first look for the number of factors. So we have 2 factors, 3 factors, 5 total factors, which means f prime has an end behavior of down, up, which means that we need to start negative and we need to end positive. Okay, so f of x starts by increasing and decreasing, and then it ends by increasing. Okay. All right. So first, we're going to look for what happens at x equals 3. And at x equals 3, well, it's an even degreed 0, which means the sign is going to stay the same. It's negative, it hits 0, it bounces and stays negative, right? So that means that our function is going to be negative, our function is decreasing, and then it still decreases. Okay. Then what happens at 5? Well, at 5, we have a degree 1, or we have a multiplicity of 1, which means the sign is going to change because it's an odd multiplicity, so we go negative to positive, which means our function is now going to increase. And then we already know the derivative needs to end positive based on our end behavior, so our function ends increasing. But again, x minus 7 has a multiplicity of 2, which means the sign needs to stay the same. So what happens? The function is decreasing. It's flat at x equals 3. It keeps decreasing. And then it must hit a minimum right here. It increases. It's flat at 7, and then it keeps increasing. So what we see is it's decreasing, it's flat, it's decreasing, right? What would that look like? Decreases, flat, decreases. Oh, it's just a shoulder, right? So we have a shoulder at x equals 3, okay, or a point of inflection is what we would call it, okay? And then we decrease, we hit a minimum and start increasing. So we have a minimum at x equals 5, okay? And then what happens? It increases, it's flat, and then it keeps increasing. Okay, what would that look like? Increase, flat, increase. Oh, it's another shoulder, right? So we have a shoulder at x equals 7. So let's say we have an f prime graph and we want to talk about what's happening to f. So let's just sketch one. It looks like this. Come on. Okay, so let's say this is f prime. So what happens is f must be increasing, but it's getting less steep. It's flattening out. It's increasing, increasing, increasing. It hits a flat point, but then it keeps increasing, right? So that's a shoulder. Okay, because then it's going to keep, so it increases, and then it flattens out, and then it keeps increasing, right? Increases, flattens out, keeps increasing. And then it's increasing, 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 increasing. Boom, it hits a max. Okay, so that's a max. And then now it's decreasing, 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 flattens out, and then keeps decreasing. So then this is another shoulder. So increasing to decreasing, that's a max. Decreasing to increasing, that's a min. Decreasing to decreasing is a shoulder, or increasing to increasing is a shoulder. And those are our different options for our critical points.